let's talk about derivatives. What does it mean to find a derivative? That means to find the speed at a certain point, at one point in a function. So let's take a car for example. The car is moving at a highway at the exact same speed. It doesn't change the speed, it just moves steadily at one pace from one point to another. So the graph of that car would look something like this. It would just be a line, y equals mx plus b, with the speed being m. So that's the speed, because if you take x sub 0, for example, here, and then x sub 0 plus delta x, plus some number, just a different number, then this would be f of x sub 0, and this would be f of x sub 0 plus delta x. So really, if you want to find the speed, you can just take 2 points here and find their slope between 2 points. And any 2 points you take on this line, any two, will give you the same slope, meaning that the speed of the car stays the same throughout the whole time. But what if a car was going on a road in a neighborhood and then was a stop sign, so it started going from one stop sign, then sped up, then slowed down, and basically the graph isn't a straight line, it looks more like this, for example. So what speed was this car moving at? Here we can just take 2 random points and use the m equals y2 minus y1 over x2 minus x1 formula. So what 2 points do we take here? Let's say I wanted to find the speed of a car at this point, right here. And I'll call it x sub 0. X sub 0 means that the point is fixed and it's not moving anywhere. So what is the other point I'll take to find the average speed? Okay, so what if I took this point? The line from these 2 points will look something like this. And as you know, the m, or the slope of this line, will be negative. But that can't be right? Because the speed of a car was increasing rather than decreasing at this point. We can see that it's lower here and then it's higher here, and x sub 0 is right in the middle. Okay, so let's take a point closer to x sub 0. Maybe that will help. Let's take a point right here. Okay. Well, it's a little less negative now, but it's still negative. And guess what? Let's take a point closer. That is the worst line I've ever seen. Okay, well now the slope is it's closer to 0. So let's keep going. Let's take a point closer. A point right here. I actually cannot draw lines today. If you imagine that this is a straight line, you can see that the slope is now positive. And as we move closer and closer to x equals x sub 0, we get more and more lines that are closer to this line. And what is this line? That is the tangent line. Just like the tangent of a circle that's perpendicular to the radius, it's the same thing but for a function like this. So it only crosses at one point, so it's not a secant like these lines. And it is actually, the slope of this line is the speed of our car at x sub 0. So if I call this point m sub 0, because it's fixed, and this point, m, is getting closer and closer and closer, as m approaches m sub 0, we get our tangent line. But how do we calculate the slope of this line, which will give us the speed? Let's go back to this picture. So we know how to calculate the slope of this line. It's just m, and to get m, you do y2 minus y1 over x2 minus x1. We know that. But the speed of the car will be exactly the same on each point, so no matter what point I take, the speed, the tangent line of any point will be equal to the line itself. So the slope will obviously be the same, which means that our derivative is actually the same as our slope. So all we need to do now is really rewrite this formula in a more complicated way so we can apply it to this picture. So let's do that. What is y2 minus y1? Well, y2 minus y1 is just delta f. Delta just means change, so it's the change in y. Because f of anything is really just our y values, right? Divided by x2 minus x1, and this is our x2, this is our x1, so it would be x sub 0 plus delta x minus x sub 0. Guess what we get? Change in f over change in x, because these cancel out, and this is what we're left with. And we know that change in f is really the difference between these two, and how do we write difference? We can just write f of x sub 0 plus delta x, this number, minus f of x sub 0, all divided by delta x. And look where we came to. They're exactly the same. So really it's just all equal to m, or our slope, for this line. And it turns out that this formula can be used to find the derivatives of any point x sub 0 on functions like this, where the car is not moving at the same speed all the way through. But let me tell you one more thing. This triangle right here is a right triangle, and it can be formed with this length equal to change of x, and this is our delta f. Let's look at this angle. I'll call it theta. Let's look back here at our delta f over delta x. That is opposite, if you look at this angle, opposite over adjacent. So katoa, opposite, adjacent. So this is really tangent of theta. So sometimes if you're given the angle, this could come in useful, because this is really f prime of x. F prime is really nothing special, it just means that it's the derivative. You're taking the derivative of x. So you're taking the speed at the point x. On this graph, this angle would be right here. You just extend it and you find the x-axis, and this is your angle, that where the tangent line meets the x-axis. So that is the basics of the concept of derivatives. It's really just the speed, and we know how we came to this complicated looking formula now. It's really just the slope. Not that scary. This will not teach you how to do derivatives, but at least you can understand the concept behind them, and why tangent of theta is really and why tangent theta is also equal to the derivative, because it's just this all over again. So I hope you found that somewhat helpful, and subscribe and leave a like. I'll appreciate it. Leave a comment if you have a question, and I'll see you next time.